I'll start in a minute. Okay, since everybody is getting quiet, let's get started. Welcome. Today we'll be talking about JavaScript and then first steps in D3. Essentially, I want to give you everything that you need to be able to successfully complete the next homework. So on that topic, over the weekend, Caroline and I have thought that it might be a good idea to move the homework labs to Tuesday so that you have more days where you can actually make use of the information that we try to communicate in those labs. But we realized that this can be a problem for some people's schedule. So who cannot make Tuesday at all but could have done Wednesday? 4 or 5 people? And no, cannot make Tuesday at all? Like, please raise your hands. And who could not make Wednesdays and this makes now possible to go? Okay, it's about the same. Who prefers Tuesdays to Wednesdays? Who prefers Wednesdays to Tuesdays? You guys are making it hard. So I think there was a slight majority, but it's kind of like a toss-up. Given that you have the advantage of seeing it earlier on YouTube when we do it on Tuesday, and the toss-up, I would recommend that we do it for Tuesday. Does anybody have a strong argument against that?
Is this for the lab?
This is for the lab, yeah. Tuesday 6 p.m. instead of Wednesday 6 p.m. And if you don't get to go and need some help, then just go to the office hours from the TAs or to any of my office hours. Okay, great. So as I said, today we'll be talking about 2 things, JavaScript and then D3. You should go to this website to simply follow along, databasecourse.net/tutorials. There's 2 different JavaScript introductions here. There is the last year's version essentially, and then this year's version is ES6. I think from the schedule I'll link either to the wrong one. We just completed this over the weekend. And so we'll be using this ES6 version here. Who's been using ES6 before? Show of hands. Like 2 or 3 people. Who's heard of ES6? Also not too many people. So what am I talking about? Well, JavaScript, as you guys know, is the programming language that we use to modify like the DOM that we use on the web to create dynamic websites and dynamic web applications. And up until recently, like the JavaScript, or in the beginning, JavaScript was not in any way standardized. It was just whatever browser supported. And then a couple of years ago, ECMA, like the a consortium, did start to standardize JavaScript, and that has kind of like gotten some traction. And then ECMAScript 5 was a standardized version that was widely popular. And now we're, like the latest release is ECMAScript 6, which introduces a couple of new concepts of JavaScript, which makes JavaScript more, let's say, amenable to building like proper large-scale web applications instead of just homepages with flickering or pop-ups and so on. And so that's why I think it's reasonable for everybody who's starting to do a new project to work with JavaScript in its latest version. So, like as I already said, up to this point we've only talked about static HTML and SVG code, and what we want to do now is we want to programmatically change the content that we see on a web page. So there's a couple of concepts that we need to cover. First, today in the first section we'll cover just basic JavaScript programming language specific. So we'll be doing things like you would do in Python or in Java. We won't be talking about manipulating a website in the first place. Because we still, like if you build a visualization application or any other web application, there's a lot of background coding usually that you have to do, and so this is what we'll be focusing on today. In the last section of this lecture, I'll give you like a quick and dirty introduction into D3. I will then again pick up D3 in more detail next Tuesday, and I will also talk about how we can manipulate the DOM using a standard API. D3 is essentially just like a different way of manipulating the DOM, but it's also really important to understand how we can do this with just the standard API, and also to understand a little bit how D3 does it behind the scenes. We'll start with JavaScript Background today. So JavaScript is mostly client-side languages, and it's kind of replaced everything else that was intended to be used on the server. So most of you probably don't have Java applets enabled anymore on your browsers. So if you want to run an old web application that still uses Java, it's going to be a security problem. And also the other option was Flash, which is now officially announced to be discontinued by 2020. So in the end, that means every time you want to do something for the web, you'll be running into JavaScript or any of the flavors like TypeScript or CoffeeScript and so on. You can also use JavaScript nowadays on the server using, for example, Node.js, but we will be only talking about client-side JavaScript here. JavaScript is kind of like a hodgepodge of various programming paradigms. So you have imperative, procedural programming, you have object-oriented programming, and we also mix in some functional programming styles. So that's kind of like neat in some way, but also you have to understand all of these concepts to be proficient in JavaScript. What is strange to some people who are used to more rigorously typed languages such as C++ and Java is that JavaScript is completely dynamically typed. So I don't ever have to declare whether a variable is an integer or a string or a float. All of this is dynamically done on the browser. There is a version of JavaScript, or I should say an extension of JavaScript, which is called TypeScript, which brings these static typing features and some other features into web programming essentially. And what you would have to do then is to transpile that to JavaScript to be executed. So I'm personally, we are using TypeScript in many of our projects. But actually, ECMAScript 6, the latest version of JavaScript, has a lot of those important features already in there. So the problem with JavaScript or developing for the web is obviously that you cannot really control for the platform of your audience. So if you develop a web application for a general broad audience, like for example if the New York Times develops for their visualizations for their readership, they have to expect that there are still some people visiting their website with Internet Explorer 6. And that is kind of problematic, right? Because Internet Explorer 6 doesn't support many of the features that modern JavaScript has. We're not expecting you guys to think of these compatibility issues here, but you should also be aware that they exist. So for our class purposes, we make it simple. We always say don't worry about platforms. We simply rely on using the latest Chrome, and whatever works in the latest Chrome is what we will be looking at in your projects and in your homeworks and so on. So however, if you want to use the latest versions of ECMAScript 6, and these are pretty radical, then you need to make sure that you at least support some of the older browsers. Like Internet Explorer 6, sure, the websites are not working anymore, but something like the latest version of Internet Explorer, like 11 before they switched to Edge, is something that you might still have to support, or previous versions of Chrome and Firefox or Safari and so on. And so what you should probably do is you should look at the features that you want to use in JavaScript and where they are supported. So here is Internet Explorer 11, and these are 2016 features. And you can see that Internet Explorer 11 basically does not yet, or probably will never, implement any of the 2016 features. So here we can switch between, this is ECMAScript 6, what I'm talking about today, and you can see that things like what we'll be talking about today, default function parameters here, the first line, let me zoom in. Default function parameters are not supported by Internet Explorer 6, by Internet Explorer 11, for example. The spread operator is not supported by Internet Explorer 11, and so on. So if you use any of these features and want to make sure that they're supported in your target platforms, use a tool like this one, to simply see which of these features do work in these various browsers. And you can see that like the common, like the latest desktop browsers generally have pretty good support for most of these features. So you can rely on that Chrome supports all of the ECMAScript 6 features. Of course, there's more recent developments that are happening and so on. Also, don't expect this versioning scheme to continue like this. So there was like 5 or 6 years of people using ECMAScript 5 and then slowly transitioning to ECMAScript 6. It's going to be more of like a feature-based dynamic approach in the future. So there will be yearly releases without any major releases and so on in the future. So what do you do if you want to write ECMAScript 6 code, which you clearly should, but also want to support other browsers? Like in very many cases, there's a couple of different ways of making your code compatible. One of them is transpiling it. So very often, like there is a backwards compatibility, and what we are doing in ECMAScript 6 is only like syntactical sugar to make things easier on top of basic JavaScript. So here is a simple example of an arrow function syntax. So this here is an anonymous function call, passes in the parameter n, and increases n plus 1. And if you run that through a transpiler, which is essentially like translation and compiling engine, such as Babel here, then it can compile it to ECMAScript 5 compatible code. And so here is the equivalent ECMAScript 5 compatible code. So here, instead of having this arrow function, you use like a standard anonymous function. So that's kind of simple to do. There's many such examples. And there's also other approaches to making your code backwards compatible. But since we're not too worried about those aspects, I'll not be going into the details here. One thing that you should be doing right now is that you click on inspect this page and then open up your console. So here you can see that like whatever is happening in any of those boxes is again output to the console. So here is like before transpile and after transpile, and if you just like add a space somewhere, it will re-execute this, and you will see the updated output down here. Okay, if you want to clear your console, you can just type in clear, and then you only see like this information here. Okay, so very basic stuff of JavaScript. Well, we can log to the console, as you just saw. Like here is a message, we can do some basic math, and we have some like constant in JavaScript, as in any other any other programming language. Of course, we can also define variables that hold values. So here we're like defining a set of global variables. Like A is 0, B is the string of 1, and here C is an array of the Beatles' names: Paul, John, Ringo, and George. D is another array with numbers, like birth years, for example. Then we have another array here where I'm mixing numbers with strings with arrays. Clearly, this is not a great idea, and you shouldn't do that in practice. But it is possible in JavaScript. So if you have a data structure like this, you should instead use an object in some way, but you shouldn't put this into an array. So like it should be a safe assumption that the data type of your array is consistent. You can have booleans, like f here. We can check the type of f. We can see it's a boolean. We can then redefine f as a float, stored as a number. So like if we, here you see this dynamic typing. F was defined as a boolean, then we are reassigning it, and now f is a number. And then we can have, like this is all global variables. So if I looked at whatever is stored in the browser window object, we would see all of these variables in there. We also have local variables in JavaScript. There's a couple of different types. Before ECMAScript 6, we only had the variable type. And in this case, name is still going to be globally scoped because it's not in an enclosing block or function. But if I had some kind of function here, then name here would be locally scoped. So outside of that function, name wouldn't be accessible. There's two new variables in ES6, variable types, that's let and const. And I'll be talking more about the differences between them. Let me just say, yeah. here is like how you define them. So let is just this keyword, const is this word keyword, and by convention, const is usually written in all caps to indicate that this is supposed to be immutable. In fact, it is not immutable, but the reference it can't be reassigned. Okay, so what's the difference between those three different types of variables? There's var, let, and const. So var is private to that function. Let is private or has scope. Var has a function scope, let has block scope, and const also has block scope. Again, only if defined within a block, with the difference that it can be reassigned. So what's the problem with that? Let's say I'm writing, like I want to store an array in a const, and many other programming languages. What would happen if I modify this array? In Java, for example. Anybody? I can still modify that array. I can, like if I say const my array is 1, 2, 3, I can modify my array. Nobody is preventing me from modifying the content of an array. What I cannot do is reassign that variable to something else. And so that is what const is preventing you from, but you should be aware that this is not a guarantee of immutability, it's just a guarantee that it prevents you to reassign it. Okay, so what's the difference between function scope and block scope? Here is a simple demonstration. Here I have a variable and the function is demo function scope. Variable A assigned the value 2, and then in here I'm using variable B in another block. So within these brackets, that's what's called a block. And if I'm looking in the function scope, I can here simply so I can simply, in function scope, I can simply output like add up A and B. But in Java, for example, that uses block scope, that wouldn't be possible. And that is also something tricky. So you're not actually like it's not necessarily great style to be able to use variables that are defined in another block in a higher level function. So anything that is private, that are defined by var or within that scope, is only private to that function. I cannot kind of like have a more detailed scope. So if I do this here, for example, with let, I'm using actually block scope. Here I have demo block scope function, and then I have one block in here, like this is out in this function scope block here, and this let b is defined in the demo block in the if scope here. And I can actually not access let b from down here, from outside that block. So if I were to uncomment this here, you would see that I get an uncaught reference. Let b is not defined. And that is kind of what is the behavior that you would expect in most programming languages, and there's very little reason to use var. So in practice, in ECMAScript 6, you should probably very, very rarely, if not ever, if not never, use var, and instead always use let. Is that clear? Any questions about that? Okay. As a general programming rule, you should minimize your use of global variables. This is like everybody has, like who's ever sat through a programming course has probably heard this. And you should never define global variables in a function. So I could do something here. I could simply say let b like this, and now it would be a global variable that I define within the function scope, within an if, and now this suddenly works. But that's not what I want to do because I'm polluting my namespace, right? And that's not very like an elegant solution in any production code. Okay, basic operations: adding, subtracting, multiplying, dividing, and so on. Here we can like a sum. We have the addition operators. We have the plus plus, minus minus operator. We can do divisions. We have the modulo operator. We have the type of operator. In this case, it would return a string number. We have we can assign the type to a variable, and we can log that then. So we can see here, this is number. And we can do string concatenation like this, so with a plus, as we have seen. I guess you're familiar probably from many other programming languages like Python or Java. Okay, let's talk a little bit more about arrays. here is a numerical array, this is an empty array. I can access the array as I would expect with indices, as in any other programming language, the indices start with 0. So let's create the output here. So the first element here is 15. I can, of course, do these multi-type arrays, and this actually works fine. So here I am accessing the second element, which is the text this, and then I'm accessing the fourth element, which is the Boolean value true. I can ask for the length of the array by accessing its like this variable in here, or this property. I can create nested arrays. So here's how I access a nested array, again very obvious. And then arrays have push and pop operations, just as you would expect. The push operation returns a new length, and the pop operation returns the last element. I can find an index of an entry, which is of course not necessarily a cheap operation. I can sort arrays. I can then pass in functions to like define what I mean by sorting, and so on. I can this, like here we have a comparator function, and so here, for example, I'm passing in this function to compare these numbers. That is, of course, more interesting if I don't want to compare numbers, but if I want to compare something that I know more about, like an object, and I want to tell the sorting algorithm what I mean by like a difference in orderability between these different objects. Okay. Arrays are pretty powerful, and they have a lot of like standard built-in things in JavaScript. As always, you should refer to the MDN web documentation to look up what arrays can do and what they can't do, and so on. So they're pretty comprehensive. So objects are the second type of compound values in JavaScript. And in JavaScript, you can also like use these objects to work as hash maps, as and or associated arrays, or dictionaries, however you would like to call them. ECMAScript 6 actually introduces a couple of new data structures, explicit sets and hash maps, but the object way of doing things is still fine. So here's how I define an object. Here again, let object is, and then the brackets, and here I have the variable name, and then here's the value. And this is all that is to defining an object. And then I can access the value of these objects in two different ways. I can access them by doing the dot notation. So value of key 1 here is 3. I can also access them by using this string notation. So this second one is really often not a good idea, because it's kind of like, especially if you use some IDE or some linting, some process that will automatically look for bugs and so on. This is very much harder to like check for errors, check for refactoring problems and so on than this notation. So if I were, for example, to refactor the name of key 1, this would be easily caught because we simply, like, I'm accessing an object or a property of an object that does not exist anymore. This here is really just a runtime evaluation. So in practice, unless you have to, and there's very few scenarios where you actually have to, you should always use this kind of notation to access the values of an object. One thing that is very similar, like if you have seen JSON before, JSON is the JavaScript object notation, which is a very popular structured file format, and it's very popular because it's easy to load into JavaScript and then work with it as objects. And so I could define an object like this, and then it looks very much like JSON in the first place. And so the difference here is that the key or the property name are also defined as a string and not directly as a variable name. But otherwise they work exactly the same. So as you can see here, string key, I can access this with the dot notation. I don't have to use the string notation here. Another thing that is kind of like strange if you come to JavaScript for the first time is that objects can be dynamically altered. So you can actually go in and change any value of, like, you can actually change the signature of an object at runtime. So here, for example, I'm taking this other object that I defined here and add a new key and simply say, like, the new key is dynamically added. And then I have the value of the new key, and then I can say access it, and it's here. it's very clearly dynamically added. So can anyone see a problem with that? So what happened, like how do I know? Yeah?
Well, you might overwrite a property that already exists, not knowing it.
Exactly, I might overwrite a property. Other potential problems with that? Well, there's also not really a great way of looking at one central place in your code to see the signature of an object, right? It's really, it can be like a pretty, like you can in various places modify and override members of any object. And that is great because it allows you a lot of flexibility, but it's also not so great because it's simply hard to discover what is in an object. And the only thing that you really can do is you can like either find every occurrence or you can look at the object at runtime to see which parameters are defined under which conditions. Okay, JavaScript has the like standard control structures. One odd thing about JavaScript is this like triple equal or triple unequal, and so I'll explain this in a second. So here I'm running through. Let me clear this again. Here I'm running through a couple of examples. So if 1 is parse float of the string 1, then we'll see yes, this works. This is the first if. However, like parse float is one function. You could instead also use the unary plus operator to do a conversion into a number from a string. So this would be essentially the equivalent thing. So if I, for example, make this to 2 and then here this to 2, then we'll see, I'll get into the, this is a little bit confusing. So we can see the first thing is I get into else if. So this works just as the parse float, the unary operator, and generally the unary operator is preferable. Parse float can do other things like, for example, if you do something like 2 meters, it will still be able to parse the 2 out of it, which is not the case for the plus here. So it's kind of like this is the stricter approach to it, and generally this is what you should use unless you have a specific reason of using parse float. Okay, so now to this operator. Why, however, do I have 3 equal signs here? Well, the problem is the JavaScript is like dynamically typed, and if you just use the double equal sign here, then it does coerce the types. So JavaScript simply tries to automatically cast in any way possible the 2 things that you're trying to compare, and if there is a cast possible, then it will just do it. So here, the JavaScript will just parse this automatically for us. And that is very rarely something that you actually want to do. So I would always be explicit. Like if you expect, like you would do an evaluation like this. So you can see that we don't see this like, well, I just passed this for you, okay? What you should always do is what we did above here by doing an explicit cast into a number, just to be safe, to avoid any bugs. So like type coercion, and that's why you should always use the 3 equal signs instead of the 2 equal signs. So if you use the 3 equal sign, this doesn't happen implicitly, so this is safer, and this is what you should always do. We have the ternary operators, like an if statement in a single line. We have the condition here is for modulo 2 equals 0, then log true, else log false. So we can see this is true. And then we have switch case statements. We can actually do this on string literals here. So we can here have like an I and switch this through. String literals, okay. We see some case that matches, so we see the switch matches here output. What is going to happen if I remove the break here? Yes. So if we don't have the break here, the case is gone through, but then it continues. There's other cases that could be matching. If I have a default here, then it will also execute the default. So here I have switch matches and default. This is behavior that we know from most other programming languages. Loops are again very much like in other languages. There's a couple of special things that we have to talk about though. So here we have the standard loop that we all know with an iterator. That is absolutely fine and absolutely okay. So we can see the output. Of the for loop here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do while loops. I can have any of these conditions in the while loops. Here I'm increasing, I'm multiplying I by 2. So you can see 3, 6, 12, 24 and so on. You can have do while loops which are exactly the same as while loops with the exception that they execute once no matter the condition. So the while has to be truthy, like this condition here has to be truthy for the body of the while loop ever to be executed. The do while loop executes once no matter what, and then checks the condition whether it should execute it again. So one thing that you'll probably use a lot is iterator-based looping over a data structure. Like here we are iterating over a year. And so there's a couple of different ways of doing this in JavaScript. Like the ECMAScript 5 way of doing this would be to use these built-in functions of the array. So it's actually like the functional approach for years dot for each. So this is not a language feature, right? This is a library feature. For each is simply an implementation of the array, a function in the array. It's not a language feature in itself. But this is like, there's many such functions in the library, but in practice, like that's fine, but then you have to pass in an anonymous function. We'll talk more about that and so on. And so there's other ways of doing this now in ECMAScript 6. So we can use the off operator. You've probably seen this for object in collection in programming languages such as Java or Python. JavaScript is a little bit unique here because the in has a different meaning. I'll talk about this soon. The off has the meaning that you care about. So for year of years, here I'm logging the years, and that just works fine. So this is kind of like the syntax if you want to iterate over a collection. So what does the for in do? So the for in do does not iterate over the collection of elements. It actually iterates over the indices. And it doesn't give you a guarantee over the order of indices. So in practice what it means, you should never use a for in loop unless you have really, really good reasons to. But I have really never encountered one. So you should either use an explicit index-based access with like incrementing your i's or your counter dynamically, or use an iterator like this, or use a function-based approach like this. These are kind of the three good ways of doing things. This is not a good way because it's also not, like the order is not guaranteed and it's kind of like, can be problematic. All of these operations are only defined on iterable objects. So this is like a special class or a special object type. And so like the array is obviously iterable. An object, the members of an object are not necessarily iteratable. It's going to work in many browser implementation, but you shouldn't be relying on it. Okay, any questions about that? Okay, so now let's talk about functions. There are three different ways of defining functions in JavaScript. This is the one that you're probably all very familiar with. I have the function keyword, then the function name, and then I have a list of parameters here, in this case only one. So what this does here, is simply, if v is smaller than 10, it just returns the function. So if I pass in here 30, or if it's bigger than 10, it returns v multiplied by v. So if I pass in 30, it will actually return 900. If I pass in -5, it will return -5. So this is fine. But then you can do some things like this. So I can pass in a string into that function where I'm using it internally only as a number. So what do you think is going to happen? Again, type coercion. JavaScript tries its best. and we'll actually parse this as a number, and you can see that we get here the string converted to the number 50 will result in the output 2500. Then if I pass in a string that is actually not compatible to the function signature, JavaScript will still try and will tell you not a number as a result. It will not give you a runtime error. If I put in like a second parameter that's never part of the signature, JavaScript also just does as nothing happens. So it will just treat like 30 as your only parameter and just ignore whatever is the rest of your function signature. Again, very dynamic because like I can dynamically modify any function signature on any object. It is simply impossible to enforce that at runtime. And so that's why JavaScript lets you do these kind of things. Even though they're function with more than parameter, we can simply, like you can see, the 900 is the correct output here. So that's a problem. And even if if you pass in no parameter at all, the function will just assume you wanted to pass in undefined. Again, not throw a runtime error as in any other language that you would expect. So this is again very flexible, but can also be tricky in practice. So the function scoping, we already talked about this. We can do things like this here. Here I'm defining this global variable, and then I'm returning x multiplied by y. Here I can simply look at the return value, but then I can also look at this global variable that I've defined down here. So z, in this case, is also defined. I can access it out here because I've run it once. But clearly you shouldn't be doing this. You should use a var or a let here, and in that case, well, it's still defined because I'm not clearing my global context here. But if I were to reload that window now, I wouldn't see the 42 here. There is now an alternative way of defining a function. So JavaScript, this is like essentially the functional aspect of JavaScript. We can define functions and then assign them to a variable. So this is like what's called like an anonymous function or a lambda expression here. You can see that this is like here we have a proper function and then we assign it to the variable function variable here. So a variable in JavaScript can be like just a regular number, a string, but it can also be a function. And I can pass these variables into any object. I can pass in functions as a parameter to other functions and so on. So that's a pretty powerful idea. And so this works as you would expect, but we can also redefine this function at a later point. So here we are redefining variable function to do something completely different, right? Here we're returning a numerical value before we returned whether it's big or small. And depending on at what point at your state you execute variable function, you get these different results. So these anonymous functions, they're pretty powerful, and we'll be using them a lot in D3 because essentially what we do quite often is we pass in a function as a parameter to another function. Okay. So we've used this sorting approach here before. Like one other thing that is a very common approach is to do any of these mapping functions. So here I'm executing another function of the array library, and I'm simply saying for each element apply this function to each element. And so what this does is it takes each element in the array and passes, while iterating over it, passes d as the current element into the function and then applies whatever is happening here. So I'm multiplying d by 2 down here. And so my numbers here in this case will simply be 26, 32, 38, 44. I've dynamically changed that array. And this way of doing things is something that we'll be using a lot in D3. And then ECMAScript 6 introduces a shorthand for anonymous function, which is called these arrow notations. So this is like the arrow notation here. So this is the parameter. This essentially tells the compiler that this is a function, and this is the body of the function with an implicit return. So instead of using this code here, like map function of D, then brackets, then explicit return, and the operation, I simply say D arrow D multiplied by 2. So again, what does this do? D here is the parameter. Everything before the arrow function will be passed in as a parameter, and everything after the arrow function, like the last statement, will be implicitly returned. So this works just fine. So if we look at my numbers here, we see that this is again the same values. Then we can also have a function, for example, with like you can use this arrow notation without parameters and simply like return 12. And we can also take these functions that we define with these arrow functions and assign them to a variable. So now we have an f1 that we can access that is defined with an arrow function. Here we have another function that multiplies a parameter, like we take in x, we assign this to the function, and then x is multiplied by 2. So you can see here that f2 for 4 is 8. Then we can have a function with 2 parameters, and we can use the bracket notation and explicit returns also in combination with arrow functions. So here you see like this method, like this little bit of simple math done to these input parameters. So all of this is possible with arrow functions. So when should you actually use arrow functions compared to any of the other function definitions? There's not a strict rule, but in practice you should probably use arrow functions if you have like single lines or very simple expressions that you want to inline into another function, but should use proper function keyword and proper function definition if you have like a longer function and want to use explicit return values. That's just like a good rule of thumb because we're kind of used to like seeing a longer function declaration, and it's easier to spot. There's also subtle differences between arrow functions and otherwise defined functions with respect to this behavior, but we'll be talking about this a little bit later. Okay, and these arrow functions, you'll be starting to see them more and more, and so this is like a neat ECMAScript 6 feature. We already had worked a little bit with objects, but now let's get a little bit into object-oriented JavaScript. And this is where JavaScript is quite different from many of the other languages that you know, and at the same time is moving more towards our syntax that we are familiar with from other programming languages. Under the hood, JavaScript is a prototype-based language. What that means is it doesn't have a class hierarchy. So there's no defined class anywhere. Instead, there's just objects floating around, but I can also do kind of something like inheritance with them. And I can clone objects and so on. So let's look at what that means under the hood. What I also should say at this point is that ECMAScript 6 introduces a class keyword, so you can actually write code now that looks very similar to what you see in other programming languages, but behind the scenes, it's still this object, this prototype-based language. And so this is only syntactic sugar that can be easily converted into the prototype approach that is classic to JavaScript. So here is a simple, here we are using functions to create something that looks like object-oriented programming like classes. So here is a create object function, and then in here we have a result object, and for that object we define a get member that contains a function that essentially just returns the content. Then we have a set function that sets the content, and then we have a twice function that multiplies the content by 2. And now here from this create object I'm returning a result. And again, notice there's no class or anything like that. I've just used these functional features and the object properties to create something like a proper object. So here I'm creating the object with something, and now I can call I can call get, and I can see, okay, I passed in something. Twice for something, the string, of course, is not meaningful. I can then set the value, now calling this this function here. And now the content is set to 20. And now if I run twice, I get the result 40. So this looks very much like an object that we created based on a class signature. So this is very much like a class signature without actually using ever a class keyword or something like that. So how can I do inheritance with this, this approach? Well, every object in JavaScript has a special field that points to another object, which is kind of like its prototype. And then every time you try to JavaScript access a field of an object, it looks at the hierarchy of like these linked objects. And if there is a member defined in the lowest level object, it will just retrieve that value. If it doesn't find a value for that lowest level object, it will look at the prototype of that object. So go up one level, look at this object signature, and if it finds a value there, it will return that. So this is very much this inheritance idea. It's better called prototype delegation, but it's like familiar for you if you have used like class-based object-oriented programming, then you know this concept as inheritance. So let's take a look at what that means. Here we have a base object, then a derived object. These are completely independent right now. So if I log them, we can see that the base v1 is 1, derived v1 is 5. So this is what we expect. These are completely independent objects. Derived v2 is undefined because there is no v2 defined here. And then we can say, like, we can call the object.set prototype of derived base. So what we're doing here is we're taking the derived object and setting its prototype to base. And now base is kind of like the parent of derived. And now if we access derived v1, we will actually get the 5 value. So this here is overridden. This is not accessed because when JavaScript tried to retrieve v1, it found the v1 in the signature of the derived of the first instant that I was accessing. But if I try to access v2, which is not defined here, then it will go back up to the base object through the prototype inheritance or through the prototype chain and retrieve v2 from up here. So this is how you can realize inheritance in pre-ECMAScript 6. And this is still how it happens behind the scene. I can also, like, there's different ways of doing this. So instead of using the set prototype of, I can also use the object create method. And the object create method takes a prototype as a parameter. So here I'm creating an empty object which doesn't have a prototype. This is just the same as initializing an object with the curly brackets. Then I have the base object, which I create with my empty object as the prototype, and then I have the derived object which I create with the base object as the prototype. So here I've set up a prototype hierarchy where this here references to this one, this references to this one. Okay, so that's pretty familiar. In ECMAScript 6 there's now added syntax for classes. And this is also what we'll be using. Like if you look at homework 2, there is a lot of class definitions in there. And this is like a very familiar syntax. So here we have a class that's called base, and then we have a constructor with first and second parameters, and then I'm assigning this dot first, like class members, like this. One thing that is not legal in JavaScript is like these class variables. So I cannot do something like this. So this is not defined. So this can be done, but I can still, like in the constructor, I can essentially define all of the object properties by using this constructor. Then I can use, like, I can add a function to that. So here I'm simply returning this dot first with multiplying this dot first with this dot second and return that value. And then we can extend that class using inheritance, using the keyword, the extends keyword, and say class derived extends base, call a constructor with first, second, and third, pass first and second to super, assign third to this specific derived value, and this works just as we expected. So if I do the multiplied here for first, multiplied by second, multiplied by third, that just works fine. And so let's look at the output. So if I have a base multiply, I can see 2 by 4 multiplies by 8. And then if I create a new derived instance with 2, 4, and 6, we can see that this also works as expected. It multiplies 2 by 4 by 6 for the result of 48. So this is kind of like exactly the same thing as what we've done here, with just a little bit more, let's say, structured syntax and easier to wrap your head around, I assume. Any questions so far? Okay, so now let's talk a little bit about this. In any other programming language, whenever you use this, you assume that this refers to the object that you're currently executing or that your current context is on. JavaScript is a little bit different here. So what do I mean by that? So let's look through this example. Here we have a function with like other object, and then we create essentially again an object signature with x value, then an accessor function and a setter function. And I can create this other object with the value of 3. And then if I output x here, we can see this is like 3 as we would expect it. If I execute the getter, this is what we expected. Then I run the setter, and then I call other.get, which is again what we expected. Getter after the set is 5 and the x is 5. So here everything is kind of like what we expected. And notice the use of this here to retrieve the getter values and to set the getter values. So this is what I'm talking about. What is the meaning of this? And actually whatever you would expect is whenever you work on an object like that this would always be relative to the current object. But it turns out in JavaScript it's not the current object, but it's the object that you're calling from. So here's what this what this can like produce, the problem that is associated with that. So here we have a very similar piece of code. X is 3. We have a getter function, and that simply prints this and then logs this, like which is the context. So that would be the object in this case, and then returns this.x, so the value that we set here. And so if we create this object, and then we see this. So this, in this case, like this is now going to be interesting with this and this and this. Here we see that this is the object, just as we would expect. So this is the output for this one. And then we get, as expected, output 3. And what we're doing here now is we are assigning only the getter to another object, like t here. So object.get, I'm assigning the function that's in this variable to t. And what you would expect is that still get would refer to the original object, right? But in fact, it just refers to the context of t. And so if I, like what the output of this here is the window. And the window is like the global context of what is going on here. And then the variable x is not defined. And so this is like one of the problems that your this context always depends on the object that you're calling it from, and that's something that you have to be aware of and take care of. Okay, here's a couple of other noteworthy new things in ES6 that make programming easier. There's now default values. So here I'm defaulting x and y to 11 and 31. Like this results in 42, this results in 5 and 11 because I'm simply passing in correct values. 42 again. Here the second variable is substituted, like the y value. Here this is undefined, is treated as missing value, so the y value is substituted. Null coerces to 0, which is kind of a bit strange, but what the result here would be 5. Here we again undefined is a missing value, so that is translated to 11, and then null is again coerced to 0, so we get 6 as the result here. So these default parameters are nice. Then we have lazy expressions, so we can also pass in functions as parameters. So for example, we could have a create unique ID function and then pass this in as a default parameter into some other object. So if you don't pass in an ID, you simply execute that function to retrieve the ID that is only evaluated when there's no parameter. There is something called a gather and spread operator. So here we have, we can simply, we have a function that takes 3 parameters, A, B, and C, and I'm logging those values in here. And by using the spread operator, I can pass in an array. This is of course more convenient if I have a complex function signature and I have that somewhere, but I'm saying dot, 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 and then an array, and that spreads out the elements of the array in the order of the function. So what you can see here is that this outputs values 1, 2, 3, just as you would expect. And conversely, there's the gather operator that is kind of like a catch-all for parameter signatures. So here I have a function that has x and y and then dot, 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 z. And if I log that and I call that function with a lot of parameters from 1 to 8 here, we can actually see that it returns, that it logs 1, 2, and then an array of all of the other parameters that I passed in. Again, that can be very convenient in certain situations. There is something called array destructing. So here I'm returning an array, and in ES5 what I would do is I would create a temporary variable, store that, and then assign temporary of 0 to A, temporary of 1 to B, and temporary of 2 to C. And then I can output that. What I would do in ES6 is I would simply say these 3 parameters in an array with this array syntax, and then call the function, and then expect those to be assigned directly into those variables here. And you can see that this works just fine as this output here demonstrates. I can do the same thing with object destructing. So here I'm returning a more complex object, and then I can simply here, I'm initializing this object, and then this is returning, and then I can simply use A, B, and C like that. And this would be the ES5 way of doing things. And in ES6, I can simply use this object, this object destruction syntax with the curly brackets here, and this is automatically assigned to A, B, and C. Also, I can use template strings now. So instead of having this string concatenation with a plus, I can use this dollar and curly brackets to refer to a variable. So this works also. This is also a new feature. Okay, so this is the review for JavaScript, ECMAScript 6. There are a couple of other important features there that are a little bit more advanced, like modules and promises, which we won't be using immediately, but they might be helpful for your project. And so we're thinking about maybe adding a course or maybe a lab to talk a little bit about promises and modules. Modules help you kind of structure your namespace and scoping, and promises are a way of dealing with callbacks and working around the lack of parallelism in JavaScript. Okay, so now let's move on to the basics of D3. I have a couple of slides, but then I'll be switching to code again. So D3 is a JavaScript DOM manipulation library. You know probably another DOM manipulation library, jQuery, but the D3 is one that is especially great for working with data and for creating visualization. And it was developed by Mike Bostock, and it's actually one of the overall most popular projects on GitHub. And it came out of an academic project. D3 was published in IEEE Viz, the conference that I also go to a lot, as a paper in 2011, and is a highly impactful and highly cited paper, of course. It's widely used for data visualization. You'll see it in the New York Times. Mike Bostock actually worked for the New York Times after he left Stanford for a couple of years, and now he's full-time working on D3 as part of a foundation to develop D3. So like D3 really works well together with SVG. This is why we talked about SVG in the beginning. So we all know about SVG already, so I kind of can skip over that slide. So what are the key D3 concepts? There's selections, data binding, scales, access, layouts, and maps. And today we'll be talking about selections and data binding, and in the future we'll be talking about scales, access, layouts, and maps. And the most important thing is actually the data binding. And so here we'll revisit this, this diagram later, but essentially what we have is a number of elements on the screen in a selection and a number of objects in a data array, and we kind of want to associate the two of them together. And you might have like already browsed. There is like D3 is very, very popular. There's many examples. There's like this massive gallery, and one of the great things about D3 is that there's so many examples, and very often the code is directly available. So if you go into any of those examples, well, here there's no specific code available, but on blocks, another like website that we'll be using a lot, there's very often like the D3 visualization and the code below it. So that like this example-based approach makes it very like easy to use. Okay, so now let's look at D3 in code. So one thing that you should always use is the D3 API reference, and then you should also look at Scott Murray's book, which is the mandatory reading in its second edition. Also notice that there's two different versions of D3. There's D3 version 3, and I guess many examples that you find on the internet are still version 3, and then there's D3 version 4. There's a couple of sometimes subtle, sometimes not so subtle changes between the two of them. We'll be using version 4 exclusively in this course, and all of the content will be version 4. But you should always make sure that if you look at an example on the internet, to be aware of which version it uses. One important difference is that D3 version 3 doesn't do a merge between selections. I'll be talking more about that later. So here's the minimal D3 example. What do we have here? Like this is again all self-contained HTML. We have HTML head element, and here we are including the D3 library. And then in the body we have two paragraphs, paragraph 1, paragraph 2. And then I'm calling D3 select on paragraph, on the element. This is kind of like the CSS selectors that we used when we did CSS styling. So that's the simplest thing, and if you were to do jQuery, this would be $, and then P, for example. And now I can apply like a style, for example, to the paragraph. Here I'm applying paragraphs.style, color steel blue. So why is there only one paragraph shown in blue here?
It's just selecting the first one.
Exactly. So select just selects the first element. What we can do, like here we selected by an element. We can also use a selection based on IDs or classes. So here's a combination. Here I'm selecting, I have 4 paragraphs, one doesn't have either ID or class, then one has ID second, then the third one has class other, and the fourth one also has class other. I'm calling D3 select on P, and setting it to blue, and calling D3 select on hashtag second, so I'm referring to the identifier, to the ID here, and then I'm calling D3 select.other, I'm referring to the class here, and set this to dark orchid. And so again, like here I have now D3 colors, and the fourth one is again not colored because I used here the select, and that only applies to the third one, to the first one. So what can I do about this? I can simply use select all, that simply selects all of the elements that match my query. So here, for example, I'm now saying I have the same example as above with these 4 paragraphs, but I'm simply calling select all on paragraph and setting color to steel blue. Now I can see that all of these paragraphs are colored in steel blue. Okay, so is it clear what is happening here? I'm like, by using JavaScript, I'm accessing an element of the DOM that matches the query in the bracket here, and then I'm modifying that element of the DOM dynamically to show me the steel blue color. And if I were to, let's say, inspect this, looking at this particular example here, then you can see that each of these elements now has a style color steel blue. And that's why I said when we talked about CSS and this inline styling that this is okay if you automatically generate it like this. It's not okay if you write HTML with all of this repetitive style is color steel blue, but if you create it dynamically using JavaScript, like here, this is again only one single declaration, so this is this is not a like frowned upon style. So what also happens here is that this illustrates nicely the declarative approach of D3. Instead of doing something like D3 select all, retrieving an array, and then iterating over that array and then applying the style to each element of this array, we simply say array, or this array of these D3 objects, and apply the style to it. And so this is like this declarative approach that makes this programming very simple, and that makes you that gives you the ability to do a lot of complicated things without actually having to loop much. So it's quite rare that you actually need a for loop in D3 code. So here we are, I'm modifying this in a different way. Here I'm again selecting all paragraphs, and then I'm appending to each paragraph a span element with the text new text in span. So if you look at this, we have dynamically modified not the styling of the DOM, but actually the content of the DOM. So here you see the paragraph element, then here what the text that was in here before, and now a nested span element that we've added dynamically into this paragraph element. So from now on, I'll be using some interactivity, and to do that, I have, like in these examples, there's a button down here. When I click that, something happens, and what happens is that this button here simply executes a function that's called execute. So when I click that button, execute is run. So this is just for your context so that you can completely understand what is going here, what is going on here, and so like I'm using this function here, so to simply have some interactivity and not to replicate this every time. So what do I have here? This is the first time we're actually looking at SVG. Like here we have an SVG with 3 rectangles. These rectangles are gray, they have an outline, and they're placed somewhere on the canvas. In this case, what we're doing now is with D3, we select all of the rectangles, and then we set the X attributes of the rectangles to 0. Then we set the Y attribute of the rectangles with a function, with an anonymous function here that takes in 2 parameters, D and I. I'm going to skip over the D for now. The second parameter here, the I, is the index of this object that I'm operating on in the specific context in the array. So for the first rectangle that would be 0, for the second rectangle that would be 1, for the third rectangle that would be 2. And so here I'm running 0 multiplied by 90 in the first case plus 50. Second case would be 1 multiplied by 90 plus 50 and so on. So what I'm doing is I'm kind of spacing out the Y position of these rectangles. And then I'm setting width, again dependent on the I. So I multiplied by 150 plus 100. And the height static is 2, and then I'm styling them as steel blue. So what does it do? Like, wow, we have now a simple bar chart that is, like, we have an equal spacing between all of these bars. So that was kind of simple, and all we did here is make use of this index, but we actually reused these rectangles in here, and then we modified them in a way that they look like a bar chart here. Okay, so far we haven't talked at all about data, but the most interesting feature of D3 is to dynamically bind data to the DOM. And this can be done by calling the data method on a selection. So we have again the same rectangle here that we had before, and we have a very similar syntax. The only difference here now is this line. Here I'm defining, like I'm selecting all rectangles, and then I'm saying with the data, bind the elements in that array to the rectangles in your selection. Okay, so I have the selection that contains 3 rectangles, and the data function here says for every rectangle, take an element out of the array associated with that rectangle, and then move on to the next one. And so my first array is now associated with 127, my second rectangle is now associated with 61, my third with 256. And now I'm like, this x and y is exactly the same. What I'm now doing is I'm doing a data-driven styling of the width of these rectangles. And so this is what the parameter d does. The d is the data that was bound to that rectangle. So we have the d and the I here. The I was the index of the rectangle. The d is the data element bound to the rectangle. And so here I'm defining the width as the value of d. And so everything else is the same. Now if I run this, you can see that the size of these rectangles corresponds to the size that I had up here. 127 pixel, 61 pixel, 256 pixel. And if I made this one here bigger with 600 pixel, and then ran this again, you would see that this is now a data-driven SVG element.
So do we define the function definition anywhere? The function we have created for 2 parameters d and I.
This is just like the map function for the array that I talked about earlier. This is by you iterate over a collection of selections, and the first parameter when you do that is always the data, and the second parameter is always the index.
It's automatic.
It's automatic in a sense, yes. So it's always whenever you whenever you operate on any of these selections and you pass in, you take a function like this, the first element is always the data, the second element is always the index. And so we can actually look at this. And now can find where the data is stored. Okay, well, I have that in a later example. I have to actually access that object here. So what it does is really binding the data elements directly to the DOM elements. And so we've done data-driven styling for the first time. Now let's do something a little bit more complicated. What I'm doing here is I have an array with 4 elements, but I only have 3 rectangles. And so what do you think is going to happen if I run that function here?
Ignore the 4th one.
Exactly, it will ignore the 4th element. And so I have to take care of elements that don't have a match in the data set. Otherwise they will not appear. And so how can I do that? There's a special selection here. So I'm calling SVG select all on the rectangles, bind the data. Here I'm simply defining the variables as I had before with the width, the data-driven width. And then I'm accessing the enter selection. And the enter selection are all the elements that where we had data items, the 71 here, but didn't find a matching item in the DOM. So we had 3 rectangles, but we had 4 data items. Our enter selection will therefore have an uninitialized object that will be bound to 71. And so after this is an uninitialized object here in the enter selection. And I have to tell that, okay, this uninitialized object is now going to be a rectangle. And this is what I do by append rectangle. And now I've actually added the 4th rectangle. And now I'm styling that rectangle with x, y values, width, height, and fill. As you can see, this is static styling here. So what I will see is the 3 data values, the 3 data-driven charts, and the green rectangle. What happens if I click run again?
One more rectangle.
I will have 1 more blue rectangle, yes. But not a 4th rectangle. It's not gonna, this is data-driven, it's not just adding something, it adds the right amount of elements. And because I already had, here I only have 3 rectangles, right? And so this code here applies to those 3 rectangles. This code here applies to the 1 element that was not initialized. So once I run this once, I have now 4 elements in my SVG. And now if I run it again, I can actually match that. So I can actually do this data-driven styling now. But of course, this is not ideal. I want to do something. We want to do better. So one way of doing this is simply copying everything that we did here for data-driven styling down to the enter selection. And this is going to work. So I'm reapplying everything that I did to the enter selection, except for the color here. The color is in green, just to show the difference. But of course, this isn't great because I'm duplicating code, right? So that's not really what I want to do. So there's a better way of doing that. Here's the shorter version. What I do here, and this is kind of like a very, very important concept. Here I'm calling selection.enter.append rectangle. So here I'm kind of taking care of all of the elements that didn't have a match, saying those are rectangles, and then I'm merging them with the selection. And now I have like one big selection that contains all of the new ones and all of the old ones together. And then I apply my styling simply to that new selection that applies to every single rectangle. So now we can dynamically add objects here. So that's kind of like the key thing. And if you will run into problems in the beginning if you play with this, but if you just look at that example, this is what you need to do, how to merge an enter selection, how to properly apply an update and an enter at the same time. So what happens if we don't have initialized any SVG elements at all, like here? What will happen if I do that now? This is kind of the same code otherwise. Any ideas? I hear nothing.
It's going to draw those rectangles.
It's going to draw those rectangles. In this case, I've only used 3 data points again. So what is weird about this? I'm selecting here on something that doesn't even exist. I'm saying, select all the rectangles that you find on my DOM, but there's none. So what would happen if I put in like line here? What's happening now? Rectangles. And so what's the problem here? Like I'm actually selecting on something that doesn't exist, and so it's kind of these I only have elements in this uninitialized enter selection, and I'm only defining what these uninitialized elements are going to be right at this point here, when I append the rectangles. So I can actually select on anything that you want to. However, you never should do that. Like I actually saw one of the co-authors of D3, Vadim Ogievsky, give a talk about D3 once, and he gave this example, and his reasoning was, if you ever do that, I will come find you and shoot you. So it's simply just not robust coding, right? There is no enforcement of doing it, but if you ever wanted to make, to also apply an update, this is going to break. Once I have an existing rectangle element that I wanted to update, this is going to break. And so therefore, you should never select on something that you don't create later, even though it's in theory it's possible.
So where are we defining the rectangle for the first 3 lines?
You're doing that here.
But enter is for the uninitialized array.
Yes, but there in this case, the SVG here is empty. There is nothing in this SVG. So like if I rerun this, you can see that this is empty. There's no elements here, and only when this is executed, then I am applying the data to this uninitialized object with the enter selection and the append. I'm making them to rectangles, and at this point I have rectangles, and then I can style them. Okay, so that D3 can select things that are in there, but we should never do that. So now let's look at what happens when we have fewer elements in the DOM. And this is basically all you need to be able to do the homework. Like styling and moving and so on. So up to here is what you need to be able to do the homework. And the rest, of course, is great to know. But I'm now talking about transition and exit and so on. And so if I don't finish that, it's not going to make a difference for your homework. So here, now I have 3 elements and only 2 data elements. And I don't do anything special here. I'm simply styling this again. What's going to happen? One of them is going to just stick around as a big rectangle here. So what we have to do here is very similar to the enter selection. There is an explicit exit selection. And so here is how we treat that exit selection. So we say D3 select all rectangles. We have again our 3 rectangles up here. We applying those 2 data elements. Here I'm styling them. And then here I'm calling selection.exit.remove. So this selection.exit contains all of the elements that match the selection but didn't match to a data element. And therefore, by calling remove here, I can neatly remove them. And so now I only have 2 bars left. This is the very basic, and these are kind of like the most important things. Just to give you like a little preview, D3 can then now do things like that for us with a single line of code added. And we'll be talking more about this next week.